Hi friends, I'm going to show you a program which is done in 8051 and I'm simulating it using Keil Microvision 4.4, and the thing we are going to see today is based on interrupt. And basically I'm doing this and I'm going to show you both the external interrupts, which are in interrupt 0 and interrupt 1. So the code goes like this. First, whenever we reset the microcontroller, it goes to the vector address 000h, and immediately I have a statement saying ljump main, which means it directly goes to the main program which we want to execute. And in the main program, I've just added two numbers. To enable my two interrupts, first I should enable the interrupts by moving the value into the IE register, and the value which we move is based on the interrupts which we want to enable. In this case, I am enabling two external interrupts 0 and 1. So the thing which we want to move in IE is 85h, and now for adding two numbers, I am moving value 3 into accumulator and I value 2 into register R1, and I am adding the both, and I am moving the value into P0, and after that I am staying in the same place. You can see sjump dollar represents means if you give sjump dollar, it stays in the same line now. And this is my interrupt routine. If interrupt 00 is enabled, it does subtraction. If interrupt 1 is enabled, it does multiplication. Now let's see the output. Now you can see this is port 1, this is port 3, and it's port 0, and now I am running step by step. Now the pointer points to the second line. Now if I run it, it goes to main, and I'm moving 85 value to IE register. As you can see here, interrupt 0 and interrupt 1 are enabled. You can see they are set high. Now I'm moving value 3 into A, you can see here, and I'm moving value 2 to register R1, and I'm adding them both. So the result is 5. 2 plus 3 is 5, and I'm moving this value 5 into port 0. So you can see here my port 0 has become 101, which represents the value is 5, and now it is in this line, the 13th line. You can see here it is sjump dollar. That means if you keep on executing, it will stay in the same line. So now if I give an interrupt, suppose I'm giving interrupt 0, I can give this interrupt by clearing the bit P3.2 0 1 2. Now if I clear it and run, now you can see it jumped to 4th line. When I enable the interrupt 00, it is going to the vector address 0003h, and from there it is jumping to interrupt 0 routine. You can see here I moved value 3 to R2 and value 2 to R3, and I am moving these value the value of R2 to A, and I am subtracting A and R3. Now I am moving the result into the port 0. As you can see, now the port 0 value has become 1. As we know, 3 minus 2 is 1. Now I gave the statement ret I. Now it will return to the position where it is before. So you can see it went to sjump. Now I am enabling interrupt 1, which is P3.3. now if I run it, first it goes to vector address 0013 here, and then it goes to ljump, means the next line which we gave, it goes to interrupt 01. Now it will execute this routine, which is I am moving values into two registers R4 and R5, and to do multiplications, as we know, the multiplication can only be done in accumulators, only the A and B. B is the secondary accumulator, So I am moving the values in R4 and R5 to the accumulators and I am multiplying them, and I am moving the result which is stored in accumulator to port 0. As you can see, the value is 6 now in port 0 here. So 2 into 3 is 6, as you know, and I am returning to the main function again. So this is how interrupts are enabled and executed. Thank you. Okay, this is the simulation in Proteus. As you can see, I've connected the circuit. This is the microcontroller, and you know from my code that I'm putting my results in port 1. So I've just connected LEDs to view my output. I've just connected 4 LEDs because my result doesn't exceed 4 bits. So I connected 4. Now see, this is where my hex file resides. I'm selecting lab hex and I'm opening it and click OK with the same frequency. And now if I run, you can see, do you remember in the code I gave the values as 2 and 3. So if I am adding 2 and 3, my result will be 5. So this is 1 0 1, which is 5. Now if I give interrupt 0, it becomes 1 because my routine for interrupt 0 is subtraction. I gave values 3 and 2 in the code, so I am getting the result as 1. Now if I give interrupt 1, that will multiply the two numbers. The two numbers are 2 and 3, so the multiplication will be 6. You can see 110 is 6. Thank you. Okay, this is the hardware output. If I play it, you can see it in hardware. You can see the addition gives 101, and if I press interrupt 1, it is giving 6, which is multiplication. If I press interrupt 0, it is doing subtraction, giving 1. These are the values stored in memory location. You can see. So whenever I press interrupt, the corresponding result gets